3.6e, we're going to look at the limit as x approaches infinity to x squared minus 4 divided by 2x cubed plus 5x. Now when we go to do our little trick that we did before, since we're going to infinity, we're going to divide by the highest degree. This is 3, this is 2. So we're going to go ahead and rewrite this as x approaches infinity. We're going to write this as x squared divided by x cubed minus 4 divided by x cubed. We're going to do the same thing here. 2x cubed divided by x cubed plus 5x divided by x cubed. So we always divide the numerator and denominator by the highest degree. So we have x cubed, 3 is higher than 2, so we choose this one. Okay, now let's go ahead and continue and reduce that some more. X squared divided by x cubed is 1 over x. And we're just going to keep this. That's supposed to be a 2. Just an x cubed. That gives us 2. And here we have plus 5 over x squared. Okay, so if we take our limit as x approaches infinity, this becomes 0. This becomes 0. This is 2. And this becomes 0. 0 over 2 is just 0. Now notice, again, horizontal asymptote. This degree is smaller than this degree, and therefore horizontal asymptote is going to be y equals 0. And look what we found. It equals 0. Okay, we're going to do another problem now. We're going to take a problem through lots of steps, okay? And then we're going to have a graph at the end that we're going to do requiring these steps. Okay, so here we go. We're going to be given a function. I'm going to call it g of x equals 3 over x minus 3. A, determine the domain. That means all allowable x values or input values. The x and y intercepts. Okay, now determine the domain. We know x cannot equal 3. So what is our domain going to be? We're not going to have 3 to negative infinity union 3 to positive infinity. So these are all numbers but 3. Okay, now to find the x-intercept, this is just a reminder, to find the x-intercept we let y equal 0. Okay, so if we let this equal to 0 and we multiply both sides by x minus 3, we get 0 times x minus 3 equals 3. 0 equals 3. That doesn't make sense, right? That's a conflict. And so when there's a conflict like that, it does not exist. There is no x-intercept. Okay, let's try the y-intercept. Now to find the y-intercept, remember we always let x equal 0. So here we have y equals 3 over, let x equal 0, 0 minus 3, which equals 3 over negative 3, which equals negative 1. So the y-intercept is negative 1, and that takes at 0.0, negative 1. Okay. Now we're going to go on to part B of the same question. Part B, find the vertical asymptote and the horizontal asymptote. Okay, let's look at the horizontal asymptote. This degree is smaller than this degree, so we know y equals 0. And how you would show that work, I guess you could say degree on the numerator is less than degree on the denominator. Okay. All right, vertical asymptote. We know x can't equal 3, so we say x equals 3 is the vertical asymptote. Okay. How about if we took the limit? What would happen? Just for the heck of it, let's take the limit for the horizontal asymptote. Limit of 3x minus 3 as x approaches infinity. What would happen here? How would we show our work for this? Well, we know that if we put in, go up to infinity, this is going to get smaller. This is going to get bigger, so this is going to get smaller, so it's going to go to 0. Okay, so again, the limit, horizontal asymptote, same answer. All right, let's go on. C, find the relative max and relative min. Okay, in order to do that, we'd have to find the derivative and set it equal to 0. So the derivative here, this is our f, this is our g. Okay, so we take the derivative of 3, which is 0, times the bottom, x minus 3, minus the top, times derivative of the bottom, which is 1, all over the bottom squared. This equals negative 3 over x minus 3 squared. Okay, to find the relative max and relative min, we'd set g prime x equal to 0 to start. And we see we have a problem here too. If we multiply both sides by x minus 3 squared, multiplying here, it goes away. Here we have 0 equals negative 3. Conflict, doesn't work. So there is no max, relative max or min.